altered its course, worrying scientists about its close proximity to Earth. A newly released image of 3IATLAS confirms it's not a comet.
And we are about to get the highest resolution images of 3IATLAS. Comes within 29 million kilometers from Mars. There are several orbiters, one that was deployed by NASA around Mars, and it has a camera.
There's this guy, Avi Loeb, he's a professor at Harvard, that believes it might be an alien probe.
Something's racing through our solar system right now. A very strange object. That came from interstellar space. It's moving at 140,000 miles per hour, and some scientists think it might be aiming for Jupiter. 3I/ATLAS, the third confirmed object from beyond our solar system, discovered in July 2025. But here's what's really wild. This thing behaving in ways that don't quite make sense. It has been breaking all the rules since day one. Multiple jets shooting toward the sun instead of away from it. A strange trajectory. And it's releasing way more energy than it's supposed to. So what is it? A comet from another star? Or something else entirely? Before we get into just how weird this thing really is, make sure you subscribe to Deep Space, because stories like this move fast and you don't want to miss what comes next. Let's find out. An insane speed. July 1st, 2025. A telescope in Chile spotted something unusual, a faint object moving at ridiculous speed through the constellation Sagittarius. At first, they weren't even sure what it was, just a tiny speck coded 11PL3Z, moving way too fast to belong here. This object was 3I/ATLAS. The math told the story. It was travelling at 61 kilometers per second relative to the sun. That's not escaped from another solar system fast. That's came from somewhere else entirely fast. Follow-up observations confirmed it. The trajectory was hyperbolic with an eccentricity of 6.139, the highest ever recorded for an interstellar visitor. For context, the famous Oumuamua had an eccentricity of 1.2. 3I/ATLAS was in a completely different league. It didn't get that speed from Jupiter or Saturn. It didn't swing by the sun and pick up velocity. 3IATLAS arrived with that speed from interstellar space, somewhere near the Milky Way's galactic center. And here's the kicker. It could be older than our entire solar system, between 7 and 14 billion years old, compared to Earth's 4.6 billion. This visitor has been drifting through space since before our sun even existed. Alien chemistry that breaks every rule. When the James Webb Space Telescope turned its instruments on 3I/ATLAS in August, it found something unexpected. Carbon dioxide. Everywhere. The comet was releasing CO2 at 8 times the rate of water vapor. That's bizarre. Most comets are water-rich, with CO2 as a minor player. This was backwards. And it wasn't just the CO2. Webb detected carbon monoxide, carbonyl sulfide, and water ice. But the ratios were off. Way off. The Very Large Telescope found cyanide and atomic nickel vapor, which sounds exotic but is actually pretty common in comets. Except this object had nickel without iron. Usually you get them together. Not here. Scientists proposed 2 explanations. Either 3I/ATLAS has an unusually thick crust hiding water underneath, or it genuinely formed in a CO2-rich environment around its parent star billions of years ago. Both scenarios point to the same conclusion. This object formed in conditions completely unlike anything in our solar system. If it's a comet, this is a fossil from a different stellar neighbourhood, carrying chemistry that tells a story we're only beginning to decode. Is this even a comet? Here's where 3I/ATLAS starts to get weird. In July, Hubble captured images showing jets of dust and gas streaming from the comet. You think, normal comet behaviour. Except these jets were pointing toward the sun, not away from it. That shouldn't happen. Solar radiation pressure blows tails away from the sun. That's basic cometary physics. Yet 3I/ATLAS had multiple jets aimed sunward, some extending nearly 1 million kilometres. By September 2025, observers counted at least 7 distinct jets. Some pointed at the sun, some pointed away. Some seemed to shoot sideways. The pattern was complex, almost structured. Now, anti-tails can occur naturally. Dust sheets can create weird geometries when Earth crosses a comet's orbital plane. But multiple analyses confirmed these weren't tricks of perspective. They were real, physical jets pointing in directions that don't fit standard models. Even stranger, the jets appeared consistent across 24-hour periods, suggesting stable surface features on a spinning nucleus. Most active comets show rapid changes as different regions heat and cool. Not 3I/ATLAS. Is it a probe? That's the question that won't go away. The strange aim toward Jupiter. Here's what really shocked community of cosmology made astrophysicist Avi Loeb write a paper. During its closest approach to the Sun in October, 3I/ATLAS experienced non-gravitational acceleration. Small course corrections caused by outgassing jets. Those corrections changed its trajectory by exactly the amount needed to hit Jupiter's Hill radius. The sweet spot where Jupiter's gravity wins over the Sun's. Think about that. A billion-year-old object just happened to make the precise adjustment needed to reach the most gravitationally advantageous position near Jupiter. This is where it gets even stranger. 3I/ATLAS is scheduled to pass Jupiter on March 16, 2026, at a distance of 53.4 million kilometers. Jupiter's Hill radius, the boundary where Jupiter's gravity wins over the Sun's, sits at 53.5 million kilometers on that exact date. The difference, 0.06 million kilometers. Within the margin of error. That's a 1 in 26,000 coincidence when you consider the full diameter of Jupiter's orbit. Loeb suggested this could be intentional trajectory adjustment. If you wanted to deploy something near Jupiter while using minimal fuel, you'd aim for exactly that spot, where orbital mechanics are most forgiving. Most astronomers remain skeptical. Non-gravitational acceleration is normal for active comets. The trajectory alignment could genuinely be coincidence. And spacecraft speculation requires extraordinary evidence. But the numbers are unsettling. What experts believe is really going on. The overwhelming consensus, 3I/ATLAS, is a natural comet. It has a nucleus. It has a coma. It releases gases that match cometary chemistry, even if the ratios are unusual. Mars orbiters photographed it as a fuzzy white dot with a faint tail. Hubble resolved dust structures. Webb detected sublimating ices. Everything screams comet, just one with exotic chemistry from a different stellar environment. The sunward jets, probably dust plumes from the heated, sunlit side of the nucleus. The CO2 abundance likely means it formed far from its parent star, beyond the CO2 frost line, then got ejected before collecting more water ice. The unusual behaviour? Probably because it's ancient. Billions of years of cosmic ray bombardment in interstellar space could have altered its surface chemistry, creating a crust that sublimates differently than solar system comets. But here's what we can't ignore. The energy budget is hard to reconcile. The Jupiter trajectory is eerie. The jet structures are puzzling. The mass loss rate defies easy explanation. Many questions still remain. Is it an interstellar comet? A fragment of something stranger? Or a probe-like object shaped by forces we don't yet understand? We don't jump to conclusions, but we don't look away either. The unknown is where science moves forward. The final countdown we all wait for, 3I/ATLAS, is moving away from the Sun, visible again in morning twilight after spending weeks hidden behind our star during perihelion. On December 19th, it makes its closest approach to Earth, still a safe 170 million miles away. Hubble and Webb are scheduled to observe it throughout December, capturing how it behaves as it cools down. Then in March 2026, the Jupiter encounter happens. NASA's Juno spacecraft might attempt observations if possible. New objects in Jupiter orbit, unusual trajectory changes. We'll know. After that, 3I/ATLAS leaves our solar system forever, heading back into the void at the same speed it arrived. But every observation between now and then's a chance to touch something truly alien. This isn't just a rock from Mars or an asteroid from the belt. This is a visitor from another star system, potentially older than our own, carrying chemistry forged in a planetary environment we'll never see. Whether it's a comet, a probe, or something in between, 3I/ATLAS is showing us that the universe is stranger than our models predict. The kind where reality turns out weirder than science fiction. Hit subscribe, deep space. And 3I/ATLAS.